Before you watch this video, you should attempt to do this problem on your own. The New York State Department of Health estimates 10% rate of HIV for the at-risk population and a 0.3% rate for the general population. Tests for HIV are 95% accurate in detecting both true negatives and true positives. Random selection of 5,000 at-risk people and 20,000 people from the general population resulted in the following tables. You could have created these tables with the information that's given like we did with the previous problem, but it's already been given to you. The first thing I recommend going through and doing is figuring out the total values for each row in each column for the at-risk population and the general population. For the at-risk population, looking at those that were infected, there were 475 that tested positive and 25 that tested negative. This means that there were a total of 500 infected in this group. Similarly, there were 225 that tested positive and 4,275 that tested negative if they were not infected, telling us that there were 4,500 in this group. In total, that gives us the 5,000 people that were randomly selected in the at-risk population. Under test positive at the at-risk population, we have 475 plus 225, or 700 people. And as far as testing negative, we have 25 plus 4,275, giving us 4,300 people. Again, if we were to add 4,300 and 700, we would get the 5,000 that were randomly selected from the at-risk population. Similarly, in the general population, we get a value of 60, 19,940, and that sum together would give us the 20,000 people in the general population. Or going down, we could have had 1,054 that test positive and 18,946 that test negative. And again, if you add those two together, you'll get your 20,000 people. The next thing that we want to do is consider a patient in the at-risk category. So we're looking at the table on the left-hand side of our data. Of those with HIV, what percentage test positive? So again, in this, we have to consider those that tested positive or those that are infected. So we're looking at this set of data right here. So of those with HIV, those that are infected, what percent test positive? We end up getting test positive given infected. So since the given information is that they're infected, that's why I circled that row. This is equal to 475 out of 500. And that ends up giving us our solution of 0.95, or 95%. The second question says, of those who test positive, what percent have HIV? So for this question, we are looking at this column of information, which is going to give us a slightly different result. So here again, what we are looking for is what percent have HIV, given that the test was positive, or infected, given tested positive. And with this, again, there are 475 that fit the group of being infected and testing positive. But now when we divide, we have 700 as opposed to 500, and that ends up giving us an answer of 0.679, or 67.9%. So notice that we can get two different answers for this because we are asking two separate questions. We're referencing two different values when we talk about these problems. One of them we're referencing those people that are infected, whereas the second one we're referencing those that tested positive. Suppose you are a doctor and an at-risk patient comes into your office and gets a category or tests positive on their HIV test. What advice would you give them? Well, considering the fact that we just found the probability that a person has HIV given a positive test was only 67.9%, we might want to recommend that they retest. So again, what we found was the probability that they were infected given a positive test Remember, when we are given information, we use that part of our graph. We were given a positive test. So there were 475 that tested positive in that part of our graph out of 700, which is equal to 0.679, or 67.9%. Now, while that is a rather large percent, you should advise the patient to retest because the test isn't completely accurate, and that'll give them more information.